All right. Good morning, everyone. Thank you for joining me today. Welcome to our Autodesk Virtual Academy on Fridays, used to be known as Fusion Fridays. This is our 65th one. This is brought to you by KETIV Technologies, of course. My name is Brian Mongkolpoonsuk, Customer Success Manager here at KETIV Technologies. And today we'll be going over some of the toolpaths I created in Fusion 360 for this X-Carve tiny little CNC router that I have here at home that I got from Inventables. So I'll show you the essentially start to end process and my thought process throughout the whole entire workflow. I have some pictures, some videos to share with everyone, and definitely feel free to comment, to chat with me as we go along the webinar today. So there's the agenda. Yeah, I just went over that. So we'll go ahead and dive right into it. Oops, there's a little miss picture there. Anyways, the first step to posting essentially code out to start my CNC routing is to make sure I have a post for the Inventables for the machine in the first place, as you will for your own CNC routers if you do have one. If you don't do CNC routing at all, then just sit tight. Hopefully this makes sense to you. So you essentially need a translator between Fusion 360 to a CNC router, which is a router that goes around and with like an end mill and cuts into the wood. So you need a translator, and that translator, if you do a Google search, if you have an X-Carve coincidentally yourself, if you do a Google search for it, there's a step-by-step process. I'm just going to drag it here to this page that you can just look for it. If you just type in Inventables posts for Fusion 360, that will be the first step that I took here. And that's, before I move forward here, let me go into Fusion. If you go on to your data panel here on the left-hand side, you go down to Assets, you go to CAM Posts. From this page that I showed you here, you can grab the post, is what they call it. Where is it? It's on this page. There it is, the post processor file. Download that locally, and then upload that into the assets here under CAM Posts. And then this is where Fusion will look to post out to G-code, to post out as directions for your CNC router to navigate. Hopefully that makes sense. All right. The next step is creating a setup, whatever raw material you have laying around. You choose a work coordinate system, point of reference for your machine or for your setup, and then the next step after that. So this is just very straightforward CNC routing or just CNC milling steps. I'll show the toolpaths that I create for that step. And then after that, I post it out on the bottom left here using this cloud post. That's the only way I'm able to see that that post that you saw earlier. I review the toolpaths inside. Inventables uses what is called easel. I review the toolpaths to make sure it's similar to what was run in Fusion 360. And then I go ahead and post it out to the machine, let it run, and that's essentially it. So with that, I will be creating this. If this looks familiar to you, it's a Fusion 360 logo that we created 4 or 5 years ago that has some more complex surfaces here. So I'll go ahead and create this and then, yeah, definitely leave a comment in the chat if you have a different way you'd want to approach it or anything like that. I do use pine wood, or not pine wood, do use man, I can't even think of the name right now. The plywood, there we go, plywood, not pine wood, to cut this. And I know that's the lowest quality of wood you can go with. So in case someone says anything, I said it here first. Yes, I know, I am aware I'm using not the best quality wood for it. So with that, I do have a setup here. We'll go ahead and create a brand new setup from scratch. So that will be step number 1. And this window popped up here on the other screen. So I have a 11 by 11 piece of plywood here at home. So if I go to my stock here, I'm going to go ahead and specify a fixed size box because I already have that raw material. And the only change I need to make here is making this 3/4 of an inch tall. And then in terms of the work coordinate system, I don't have any way to probe for the middle there. So, but I am able to use just a ruler and measure to the middle of this edge here from end to end. So I'm going to use that as my work 000 origin. I think it was G54 officially. So I'm going to go ahead and specify that top edge there. Then we can go ahead and move into the toolpaths themselves, quite frankly. So there's a bunch of different options we can choose from. I did do adaptive for my actual cut, but what Alex, my colleague who helped me out with this, recommended also was to take a look at the 2D Pocket, because that's what this is essentially. The 2D Pocket toolpath, which is actually kind of like a hybrid. It's a hybrid kind of toolpath. It can be used for roughing, but it can also be used for finishing operations. So I'll go ahead and select the 2D Pocket toolpath. And then let's go ahead and specify our tools. It's already actually selected the correct one because I already had some set up here. But essentially, let's go ahead and look at some of the tools we have access to. It first by default just shows what you're already using in here. But if you go to the Fusion 360 library, for example, we'll go ahead and filter for a flat end mill. I do have a 1/4 inch end mill, but unfortunately it kept sliding in the collet. Apparently I needed a stopper. Let me show my PowerPoint here real quick. I needed this stopper that came with the machine, this turquoise colored part of the end mill there, whereas the other ones I bought by default don't have that. And long story short, I just needed the stopper. It wasn't tight enough for those other tools. So I ended up having to choose an 1/8 inch end mill. So I'll go ahead and use a 1/8 inch flat end mill, and a flat end mill because I need to get this flat surface there. Feeds and speeds. These depends what machine you're running. My machine, you control the speed by a manual twist of the knob of the router head. So we don't actually have to worry about this specifically because it doesn't do anything to that. But it's just good to keep in mind for some of the other features, kind of like maybe the speeds in which it approaches it. But since we're cutting wood, it goes pretty seamlessly through it. Like it's not even a problem. So I'll go ahead and hop to the next tab here, geometry. We'll go ahead and tell it to, since this is a pocket cut, let's try selecting those two profiles there. So I selected this outer one and that inner one because I don't want it to machine the F part there. And then we can look at heights. We do recommend to kind of contain or create toolpaths based off heights for sometimes pockets or horizontal maneuvers, because then you can reuse the toolpath, or if anything were to change in the middle there, it's going to reference it based off heights rather than geometry that might have changed. So keep that in mind. I'm not going to use it for this one since I already selected the profiles because I didn't want it to machine my F there, but just keep that in mind. when creating those toolpaths. Now passes, the maximum step over, it's telling me 0.125. That's actually pretty aggressive since that's the entirety of my tool here, which is 0.125 for my 1/8 inch. But we'll go ahead and actually no. Well, sometimes the best practice in general is usually about 20% to 33% of a step over of the tool diameter. So it'd be the tool diameter times 0.25, for example. And you could put mathematics into the equation here. So that's an option that you have. And stock to leave, I'll leave about 50 thou. So then I can do a finishing pass later. I'm not going to do a semi-finish in this example. Linking, the only one I really want to focus on right now is the ramp type, just to save time. I don't necessarily need to helix into my model. I will just actually plunge into it because it's easy to cut through wood. And let's take a look at what we have so far with this toolpath and see if I need to change anything. It's always good to simulate it. And then I also want to see time and see if I can narrow down this time. So of course, if I use my 1/4 inch end mill, if I were to get that to work properly, this would probably reduce it by half right off the bat. And then the other one, maybe if I went more aggressive with my in my step over rather than 0.03, which was the 25% of my tool diameter, I actually went 50% on my actual cut. So that's about 0.125 times 0.5. So let's see if that reduces the time at all. Simulate, there it is. So that actually reduced it by half for obvious reasons. So that helped a lot. So if I use a 1/4 inch end mill, that will help even more. Maybe like an 8-minute roughing operation there. All right, so next, let's go ahead and do a finishing operation. So I'll go over here and look at, let's do the horizontal. Let's see if it says it says that at the last sentence there for both semi-finishing and finishing. So if you're curious if it's a roughing or finishing pass, you can essentially look into the description. It might tell you there. So it's very, very, very similar to the pocketing toolpath because you'll see the toolpath look almost exactly the same. Machining boundary, I'll give it the same selections and I'll tool inside the boundary. I won't give it an offset. I did use heights previously, but I steered away from it because it was giving me this weird entity as part of it. But again, you can use heights for moving forward to kind of contain your tool pads. Everything looks good here. Minimum cutting radius, manual step overs, and then we'll make sure it plunges again to save some time there. Let's take a look at how this toolpath looks. So yeah, again, looks very similar to the pocket. There's the pocket, there's a horizontal. It's very similar, but this one will not leave material. And like if I hover over that picture, you can kind of see where it kind of, if it were to have a different kind of approach, if it wasn't a pocket, let's say it had an overhanging feature or potential, it would just cut right across that to give it a nice finish. Hence why you'd want to use something like the horizontal toolpath to finish your models. All right, so after I made these two toolpaths, what I went ahead and did was I held control, selected both of these, and we're actually gonna go ahead and post this because The reason being is because I do a tool chain to a ball end mill after this. So I'm already ready to go with the front end of my toolpaths, and I also wanted to paint that part right here. So we'll go ahead and post these two toolpaths. And if I go here to these three dots, or sorry, is it the setup? Yeah, it's under setup. I'll use Cloud Post. It was already set up like that, so nothing changed. But then you can see that this easel / F360 option configuration has popped up. And this is the same one that you can reference inside of your assets. Just to recall, it's this one right here. All right. So that is the same post there. Once I hit post here, we can put it as at a location. I have this 1001 location here on my desktop. So I'll go ahead and save over that. And then let's see if it pops up the G code. Yes, it does. Looks like I have Visual Studio. So it popped my G code popped up in here. And you can review it however you want, just to make sure it's aligned with what you had inside of Fusion 360. And just keep this location in mind, because now, and this is going to be outside of Fusion a little bit here, but inside the machine or the software, Inventables uses Easel. It's like the software to run the G code. I'll import that G code just to give you a quick example of what it looks like. So there it is here. It looks essentially the same as what I would expect it to look. So once this is ready to go, this would be hooked up to the machine. I would hit carve here, and then it'll be on its way. And I will go ahead and now show. So this was, I ended up using the 1/8 inch end mill. And let me see if this is muted, because it's gonna be loud. There you go. So I ended up using a 1/8 inch end mill, but I actually typed in a 1/4 inch. That's why it had these spirals. So I had to stop that. But now I threw in I changed the toolpaths to run an 1/8 inch. So now it's going to cut as expected. Right now it's a very loud router noise of this router, this DeWalt 611 going in there and just cutting with my 1/8 inch flat end mill. So you get the point. It just keeps on going. And that's the first cut here. And then that's what we get as a result. These two dots was a result of part of the code that I messed up. So that was my fault. But I showed you the right way to go about it with the toolpaths. And then I went ahead and painted it. Terrible paint job, but I painted it to kind of look like the, let's see here, to look like that, to try to make it look like that. So you can see the F as emphasized as possible. And if I go one further here, we can make that look a little bit better there. So right now we're at the step where essentially it looks like this, and it's painted, and this part is painted. So now we just need to cut out the middle F part. And to do that, we can do another type of roughing operation, which we'll be using the adaptive clearing tool. And then we will be using another finishing operation to do so. So let's go ahead and we're going to use the same setup, because I'm still going to be referencing that part. That part hasn't changed at the top middle of my model. I'll go straight to let's go adaptive clearing tool. Instead of a flat 1/8 inch flat, we're going to use a ball end mill 1/8 inch. And in terms of geometry, let's select just this this part of, I need to select this one here. Let's go selection. Let's select this part of the sketch there, or the model. And heights are fine. Passes, stock to leave. Again, I'll change this to 50 thou. And in terms of the step down, I am okay with going aggressive. I did not go as aggressive the first time around, and it took too long. So I am okay with going pretty aggressive with the cut. This is about a 0.5, I want to say half-inch pocket. So I am okay with going about 0.39 down there. And then let's see, the optimal load. All right, we'll leave everything else as is for now, but the roughing, the step down can be pretty aggressive because it's just wood here. And in terms of linking, again, we'll just go ahead and plunge right into it there and see what we get so far. And what we might have mentioned in the past is our with the adaptive clearing tool pads, Autodesk, that we got from, I think Autodesk purchased from HSM or High Speed Machining, is just a very very efficient algorithm toolpath that was created to be very efficient with approaching the target there without giving longevity to your tools, so it won't be essentially crashing into the stock at a high rate. It would go and lead in slowly. It would make nice turns around the corners and things like that to make your tools last longer. But with wood, maybe it could be a little bit more flexible. So there's my adaptive clearing toolpath. Let's take a look at how long that's going to take us. It looks about 20 minutes. And then the finishing operation, again, I'm going to skip over the semi-finish. The finishing operation, we'll go ahead and choose let's go with the Morph Spiral toolpath here. And again, it says, maybe it doesn't say it for this, but this is the finishing toolpath we'll be using. Ball end mill again. So yeah, all this stuff, a lot of this we don't have to kind of reselect. But what I will select is the geometry here. Let's select the F linking. Oh yeah, I guess it's not going to helical into it because it already assumes it's pretty cleaned up. And there we go. There we have that very nice finishing toolpath with the Morph spiral, which is really nice. So if you make some complex surfaces like this, definitely recommend the Morph spiral. Looks really good on for your models, whether it's wood or maybe metal. All right, so now that I have these two ready, just like we did previously, we'll select those two and then we'll go ahead and post them out. And I don't really necessarily, it's the same thing as what I did before. So I went ahead and posted out, and I'll just show you the PowerPoint of what that looks as an end result here. Oops, sorry about that. Sorry if I just destroyed your ears right there. There's me vacuuming some of the F here. The tool slipped. Like, this is a hardware issue that I was having. As you can see, these gauges here into my F, and there's some right there. But the rest of it went pretty well. The reason why it's not, or why it's so fuzzy is, one, it's because it's plywood, like I mentioned earlier. But two, I'm actually using an end mill here. So there's a lot of things that I could have done better second time around, hindsight, because I didn't actually have the 1/8-inch end mill for this machine. I have a regular, or sorry, not end mill, ball end mill. I have a regular ball end mill that doesn't, for whatever reason, doesn't work because it slips with this machine. But overall, I still got what I wanted to get as an end result. And here's the comparison between the original model and the finished design. You can see the big dent there at the bottom, but nobody's looking at that, right? So anyways, just wanted to just give everyone like documentation of the process from start to finish of a CNC router. Just wanted to see if that was helpful, because I know sometimes just walking people through each step can sometimes be helpful because they're doing it themselves and they're curious of how to do it. So that's pretty much it. Thanks everyone who for sticking through all the way through there. I hope that was helpful, and definitely reach out to me via email, or just reach out to us like as KETIV as to what you'd want to see moving forward in the future, whether it's more CNC routing, or if you want to see more 3D modeling. Definitely open to any topics you guys suggest. So let me see if I'll wait around another minute or so to see if anyone has any questions. But if I don't talk to you before then have a wonderful weekend.